Okay, so for the last subtopic of chapter 1, it is subtopic 1.3, which is about factors that affect the reaction rate. Here are the learning outcomes for 1.3. So, A, explain the effect of the following factors on the reaction rate. Okay, so for this part, I think you akan belajar more about it in experiment 1, okay, where you akan study the effect of these following factors. Ada few je lah factors on the reaction rate. And then B, you need to illustrate the effect of temperature on reaction rate by using Maxwell-Boltzmann distribution curve, and then compare the curve of the energy profile diagram for a reaction with and without catalyst. Alright, and then state the Arrhenius equation. Explain the relationship between temperature and activation energy to the rate constant based on the Arrhenius equation. And lastly, determine K, EA, T, and A by using Arrhenius equation by calculation and graph. Here are the terms untuk yang kamu familiar with. Okay, the first is effective collision. Apa tu effective collision? Collision yang akan menghasilkan product. Okay, activation energy pula EA. Okay, this is symbol untuk activation energy EA. Activation energy ialah minimum energy yang diperlukan untuk kamu start a chemical reaction. And then kinetic energy pula ialah energy yang dimiliki oleh particles bila dia bergerak-gerak. Okay? Catalyst pula ialah chemical yang digunakan untuk increase the rate of reaction, tapi dia tak akan di use up in the reaction tersebut. And rate constant simbol dia ialah K kecil. That is rate constant. Okay, rate constant, you boleh dapat rate constant ni adalah melalui pengiraan, okay, melalui order of reaction, dia punya unit dia tu melalui order of reaction, okay. And the rate constant ialah constant yang specific to reaction yang akan menentukan how quick a reaction can proceed. Alright, there are 5 factors that will affect the rate of reaction, such as concentration, pressure, size of particles, catalyst, and temperature. Okay, for the first factor yang akan affect the rate of reaction ialah factor concentration ataupun pressure. Okay, yang this one dia hanya tertakluk pada solution yang aqueous ataupun gas phase sahaja ya. Okay, kalau let's say the higher the concentration ataupun pressure, the faster the rate of reaction. Bila kita bercakap pasal rate of reaction, kita bercakap pasal kadar, pasal rate kan. So it's gonna be slower or faster. So actually kalau ikutkan, the higher the concentration ataupun pressure, the faster the rate of reaction. So we can say here, okay, concentration ataupun pressure is directly proportional to the rate of reaction. Okay, sebab semakin tinggi concentration ataupun pressure, semakin tinggi the rate of reaction. Sebab apa? Ni dia punya explanation ni, you wajib lah. You tak boleh lah bagi tahu dua benda ni je. You kena bagi tahu isi dia. Kenapa bila the higher the concentration, the faster the rate of reaction? Because the number of particles per unit volume will be higher. So bila number of particles per unit volume tu, okay, if you look at this one, bila you tinggikan concentration dia, so the number of particles per unit volume ni tinggi. Okay. Therefore, you akan tingkatkan dia punya chance untuk effective collision ni berlaku. Kenapa you nak pentingkan effective collision sebab effective collision ni ialah syarat-syarat untuk daripada reactant jadi produk. Kan? So, bila dia punya number of particles per unit volume tinggi, so dia akan meningkatkan the chance of effective collisions, okay, to occur between the reacting particles, and therefore the rate of reaction will increase as concentration ataupun pressure increase. Alright, the next factor yang akan affect the rate of reaction ialah size of particles, but this one only applicable for solid phase sahaja ya. Okay, so kat sini kalau let's say size of particle tu kecil, makanya the total surface area exposed will be increased. Okay, so bila size of particle decrease, total surface area exposed untuk buat perlanggaran, untuk buat collision ni will be increased. Okay, and dia akan menyebabkan the chance of effective collision to occur will be increased as well. As a result, the rate of reaction will be increased. Okay guys, for the next factor yang akan affect the rate of reaction ialah factor catalyst. Okay, catalyst ni dia dapat speed up the rate of reaction by providing an alternative pathway. Bila dia dapat providekan shortcut, makanya dia dapatlah lowerkan the activation energy. Okay, so bila kamu nak terangkan pasal catalyst punya effect on the rate of reaction, you tak boleh bagi tahu catalyst ni hanya speed up the rate of reaction. You tak boleh bagi tahu catalyst ni lowerkan activation energy. Okay, apa yang you kena bagi tahu? You kena bagi tahu dia speed up the rate of reaction by providing an alternative pathway. Sebab dia akan, bila dia dapat provide the alternative pathway, dia dapatlah dia dapatlah lowerkan the activation energy. So 3 poin ni sangat penting bila kamu nak menerangkan about the factor of catalyst yang akan affectkan the rate of reaction. Okay. Sebab 3 poin ni baru you dapat 1 markah. Kalau you bagi salah satu, you dapat 0 mark. So 1 mark is better than 0 mark. Berharga kan 1 markah tu. Okay, next ialah pasal activation energy. Kenapa kalau lowering activation energy ni akan speed up the rate of reaction? Sebabnya, bila kamu lowerkan the activation energy, makanya effective collision ni senang nak berlaku. So ni yang poin kedua yang you kena mention. Effective collision senang nak berlaku. Okay, which will result in a higher rate of reaction. Okay, kenapa kita pentingkan sangat pasal activation energy ni? Sebab kalau kamu nak make sure reaction tu berlaku, okay, the reacting particles ni kenalah buat effective collision supaya dia dapat produce products. Okay, kena buat effective collision supaya dapat produce product. And one of the requirements untuk effective collision ni, the colliding particles tu kenalah ada energy that is greater than or equal to activation energy. Okay, so these are the common misconception for the student. Sometimes student hanya fikir catalyst ni dia hanya akan lowerkan the activation energy je. Salah. You kena mention, sebab itulah you kena mention juga pasal dia provide an alternative pathway. Bila kamu cakap dia hanya lowerkan the activation energy, that means you macam discard the idea yang catalyst ni akan provide a shortcut tau. Okay? Sebab bila you ada jalan shortcut, tak semestinya jalan lama you akan hilang. Jalan lama tu still ada. Okay? Cumanya bila you provide shortcut, dia hanya akan lagi memendekkan perjalanan tersebut. Kan? So that's why penting untuk kamu mention provide an alternative pathway. Okay? Just because there is shortcut doesn't mean the long way is gone. Okay, so these are the energy profile diagram untuk activation energy yang without and with catalyst. So itulah pentingnya untuk kamu reti nak lukis energy profile diagram dekat subtopic 1.2 tadi Miss dah bagi tahu kan. Okay, kalau y axis mestilah potential energy. Okay. Kalau x-axis, it can be reaction progress, boleh jadi reaction pathway, okay, boleh jadi reaction coordinate, tak kisahlah kan. Tapi kalau exothermic, kalau energy profile diagram for exothermic, okay, exothermic ni ialah di mana bila enthalpy change dia equals to negative sebab the heat is released from the reaction exothermic. Endothermic process pula dia punya enthalpy change dia is equals to positive. Okay, positive sebab heat is absorbed. Okay, and then kalau exothermic kita dah belajar tadi previously on subtopic 1.2, energy profile diagram for exothermic, dia punya potential energy of the reactant must be higher than the potential energy of the product. While endothermic, the potential energy of the reactant must be lower than the potential energy of the product. Okay? Lepas tu, kalau you nak lukis activation energy with or without catalyst for exothermic, okay, this is jalan lama. Okay, jalan lama Miss highlightkan dengan highlight color apa ya? Color hijau lah. Okay, this is jalan lama. Okay. Jalan lama, this is the activation energy of exothermic process without catalyst. Okay, point activation energy as what I have ajar you time energy profile diagram, nak lukis energy profile diagram. Activation energy ni ialah di mana energy difference between maximum potential energy dengan potential energy of the reactant. So this is without catalyst. Tapi bila you letak je catalyst, apa yang berlaku? The rate of reaction will be increase. Sebab kenapa? Sebab catalyst dia provide alternative pathway, dia provide shortcut. Okay, so ni jalan baru. Jalan baru Miss highlightkan dengan highlight color orange lah. Okay, ni jalan baru. Dia provide an alternative pathway, dia provide shortcut. So kejap Miss. Okay, and then this is the maximum potential energy and this is the potential energy of a reactant. Okay, so the energy difference between maximum potential energy and potential energy of the reactant ni ialah activation energy with catalyst. With catalyst. Alright. So if you look at here, sebab itulah pentingnya untuk kamu mention sekali yang catalyst ni provide alternative pathway. Tak boleh bagi tahu yang dia hanya akan lowerkan activation energy sahaja, sebabnya jalan lama ni tak terpadam lagi. Jalan lama still ada. Contohnya, this is the minimum energy required untuk reactant bertukar kepada produk. Minimum energy dia setinggi Gunung Kinabalu. Tapi bila you letak je catalyst, dia punya minimum energy dia setinggi bukit dekat Kundasang. Okay. Bukit yang rendah, setinggi bukit kan rendah. So kiranya catalyst ni dia provide alternative, dia provide shortcut, jalan pintas untuk reactant pergi ke produk by lowering the activation energy. So bila dia lowering the activation energy, makanya the effective coalition punya chance untuk berlaku lagi tinggi. So that's why dia akan speed up the rate of reaction. Okay. So if you look at this endothermic pun sama juga. Okay, memula you lukis dulu activation energy without catalyst. Okay, nak lukis activation energy without catalyst, you kena remember activation energy ni ialah at the maximum potential energy. Maximum potential energy ni di mana you punya transition state berada. Okay. So between the energy difference between maximum potential energy dengan potential energy of the reactants. Okay, so you lukis dulu the activation energy yang without the catalyst. Okay, so Miss akan highlightkan kalau yang jalan lama tu dengan color hijau ni lah. So this is the activation energy without catalyst. Okay. This is the activation energy without catalyst. Tinggi kan gunung dia ni. Dia punya minimum energy. Okay. After that, barulah you lukis activation energy with catalyst. Okay, bila activation energy with catalyst, dia punya activation energy ni punya jalan jadi rendah. Okay. Sebab apa? Catalyst dia provide alternative pathway. Okay, this is the maximum potential energy. This is the maximum potential energy untuk activation energy with catalyst, and this is the I'm sorry, silap sis. So kiranya dari sini sampai sini sebenarnya, sebab activation energy ialah energy difference between potential energy maximum dengan potential energy reactant. Okay, so it should be from here until potential energy reactant. So daripada sini sampai ke bawah ni. So this gonna be the activation energy with catalyst for endothermic process. Okay, activation energy for reactions with catalyst ni, you kena make sure activation energy mereka rendah daripada yang original punya, yang without catalyst. Okay, that's why the products can be formed faster. Bila produk boleh form faster, bermaksud rate of reaction tu cepatlah. Okay. Okay, Miss nak kamu cuba buat soalan ni on your own. Okay, cuma untuk soalan ni, Miss nak terangkan sikit lah. Kat sini dia kata zinc oxide is added to the reaction and the rate of reaction will be increased. So, apakah function of zinc oxide ni? So, bila zinc oxide ni dia added, reaction increase, bermaksud zinc oxide ni ialah catalyst. Okay, bermaksud zinc oxide ni ialah catalyst. Sebab dia increase the rate of reaction bila dia add di dalam proses ni. Okay, and then next ialah dia suruh kamu scratch a graph of concentration versus time for the reaction with and without the presence of zinc oxide. Okay, zinc oxide ni tadi kita cakap apa? Kita cakap zinc oxide ni ialah catalyst. Okay, so bila you nak buat graph of concentration versus time, this one, okay, what you need to do ialah you kena rujuk table yang zero order, first order dengan second order for graph concentration versus time. Okay, so if you look at here, how you boleh tahu curve dia macam ni ke, dia straight ke apa ke? You tengok graph of concentration versus time. Kalau graph of concentration versus time, normally you relatekan dia dengan half-life punya graph. Okay, and then kalau you nak tahu half-life punya graph, if let's say if it's the first order, you akan dapat straight line. Kalau first order pula, kalau zero order, you akan dapat straight line. Kalau first dengan second order, you mesti dapat macam ni. Okay, and you tengoklah, how can you know that you dapat macam ni? Sebab you look at your rate constant punya unit. When you look at your rate constant punya unit, you will notice that unit yang digunakan ialah per second. Okay, so kalau unit per second ni, bermaksud it is a first order reaction. Okay, so kalau first order reaction, for graph of concentration versus time untuk first order reaction, it's gonna be melengkung macam tu kan, and then half-life dia must be constant. Okay, tapi tak kisahlah pasal tu, sebab dia nak suruh kamu pasal half-life tu kita tak kisah sangat, sebab in this case yang dia kisah ialah dia suruh kamu buat graph with and without the presence of catalyst. So you tahu if it's first order punya reaction, you should get graph yang melengkung macam ni. So bila you nak buat graph concentration versus time, so your y-axis should be concentration of your reactant. Which one you punya reactant kat sini? Your reactant ialah HCOOH. This is your reactant. Okay, so concentration of your reactant HCOH versuskan dengan time. Time since that dia tak bagi sangat unit, so you just boleh biarkan begitu saja. Tapi yang penting kat sini dia nak suruh kamu sketch graph yang menunjukkan presence of catalyst. Okay, so sekarang ni you buatlah dua. Kalau yang satu ni yang kat atas ni without zinc oxide, yang kat bawah with zinc oxide. Kita nak cakap apa kat sini? Kenapa dia kat bawah with catalyst, dia punya curve tu lagi ke bawah? Sebab apa? Sebab kalau you macam tengoklah, this is the time taken kan. So time taken dia lagi cepat. Okay, time taken dia lagi cepat. So bila time taken untuk concentration yang with zinc oxide ni lagi cepat, that's why dia punya rate of reaction dia lagi increase. Okay, while the curve yang untuk without zinc oxide, dia atas sikit sebab dia takes longer time. Okay, this one dia takes longer time. That's why lah dia berada di atas. Okay, next Miss nak terangkan pasal factor temperature yang affect the rate of reaction. So I would like to say yang actually temperature ni is directly proportional to the rate of reaction. Because why? The higher the temperature, the faster the rate of reaction. Okay, sebab kenapa? Bila temperature ni tinggi, particles tu ataupun molecules tu punya kinetic energy will be high as well. Okay, and this will increase the chance of effective collision to occur, and therefore the rate of reaction will be increased. Okay, so if pasal temperature yang affect the rate of fraction ni, it can be explained more by doing the Maxwell-Boltzmann distribution curve or Arrhenius equation. Okay, so Maxwell-Boltzmann distribution curve akan menerangkan pasal faktor temperature affect the rate of fraction, also Arrhenius equation. Okay, so these two things ialah dua benda yang berbeza, tapi these two things akan masing-masing ada explanation dia yang unique about how the temperature affect the rate of fraction. Okay, so first of all, Miss nak terangkanlah pasal Maxwell-Boltzmann distribution curve yang menerangkan pasal faktor temperature yang affect the rate of fraction. Okay, so what is Maxwell-Boltzmann distribution curve? Okay, Maxwell-Boltzmann distribution curve ni ialah a statistical distribution graph yang akan tunjukkan distribution of kinetic energy of particles at any given temperature in Kelvin, and actually at any given temperature not all particles ada same amount of kinetic energy. So that's why kita kena buat Maxwell-Boltzmann distribution curve.